Good afternoon. It's going to be my pleasure to summarise the discussions we had in the Track 1 sessions on utility experience and concerns. Basically, I think the most important thing is that I can get done on time so that everybody can make their taxis, because I understand what it's like when you haven't finished and everybody gets out of the room and they're all leaving, and so we're going to get done. The summary slides that you see are a synthesis of information. These are the people who, at least as far as I'm aware, were attending the session 1. Everybody involved was involved in the discussion. Everybody involved has reviewed the summary that I'm going to get to. So all the credit for the summary belongs to me, and all the blame belongs to everybody else. The desired outcomes were what we started with. That was what we had from John Shingledecker and Tony Fry. This is what we should have been discussing, but now we are talking about what we actually did discuss. We had 7 presentations, 6 of which had formal visuals, and I'm assuming that the visuals from these things will become part of the deliverable from the meeting. The 7th presentation, Barry gave us some up-to-date information on current practices at CS Energy in Australia. All the presentations were of great interest, were relevant to our topics, and were subject to a great deal of discussion. All the presenters answered all the questions very well. We didn't have to get the thumb screws out even once. So we went through those presentations, and in fact we went on till about 5:30 yesterday and went through this morning. And then we threw together a list of issues. One of us had actually suggested some of the issues before we sat down and got together today, but I don't want to suggest that I was influencing the other members of our team. But Rudolph, my good friend, said, "I can see your list has got no sense or no strategy to it." So he forced me to colour code these different topics, and we colour coded them into 3 areas: existing plants, future plants, and understanding. And then John Shingledecker shared with the group that I'm colourblind, so if these aren't really blue, red and black, please excuse me. Okay, so sneakily on our first list, and I have to say, we did a certain amount of wordsmithing here. We had a certain amount of discussion about whether we should actually use words like risk or damage and things. We think these capture the synthesis, but I've cautioned my colleagues that if there's anything here that they want to jump up and disagree with, they should do so. Clearly, under existing plants, what we were primarily concerned with was what can we do, how can we help people who've got equipment at the moment, whether that be with operating or maintenance planning, or whether that be with refurbishment type issues. And we're going to run through each of these point by point. Most of these were just put together to be a memory aid, if you like, so that we can capture the issue. But clearly, our first thought was that often when plant is put together, there are guidelines prepared for operating conditions associated with strength. There are guidelines associated with operating conditions associated maybe with corrosion resistance. And maybe we needed to have some guidance, with the emphasis on the word guidance, not specification, associated with exfoliation. So looking for some time temperature precautions that would help to avoid damage. And the discussion we had went around the fact that it was going to be impossible never to have a situation where exfoliation could occur. In fact, it probably wasn't even desirable to strive for a zero situation, but that we should help people with guidance so that they could manage it properly within their overall asset. So that's our first point. I'm assuming that you want me to kind of rattle through these, and if everybody's still awake at the end, we can see if there are any questions about it. I mean, and there may well be overlap between the list that we prepared and the list that the other group has prepared. Since I was only in this group, I have no idea whether this is going to be the same kind of thing. There was a concern about when people had exfoliation, how did you identify where the scale had come from? In other words, which part of the boiler, which original material? It was clearly the case that certain experts could probably identify that, but would it be possible to give further guidance on how to identify where the scale had come from, which type of steel it was from? And then there were questions of, is there a consistency of thickness? In other words, does exfoliated scale from a 2 1/4 chrome always look the same and have the same kind of thickness? Are there certain patterns that we can get? And we felt it would be helpful to the industry if that kind of practical mapping was there. We had lots of discussions associated with managing exfoliation. If you had it, how could you prevent it causing you outages? How could you prevent it causing you forced outages or extended forced outages? So clearly, one option was that if you had it, you would try and exfoliate it in a controlled manner after a period of operation that was going to be appropriate. In parentheses, it says so that the oxide's not too thick, and then you would blow it away so that you weren't getting tube blockages. And there are lots of opinions on that. Various people have got certain time frames of operation. There are different manufacturers who have different recommendations. By and large, the consensus in the group was that there was no independent understanding of the engineering basis for some of those guidelines. They seem to have been developed through, I hate to use the expression trial and error, but they seem to have been developed by trial and error. So what we were going to try and do was to put some engineering structure on that. Several utilities have been living with the effects of solid particle erosion. It can occur on 90-degree elbows, it can occur on various tees or drains, it can even occur on valves. And can we help utilities run their plants more by mitigating those effects? And we heard from one of our presenters where they were mitigating the effects by doing away with a welded pressure boundary. They were coming to a flanged pressure boundary so they could make it easier to replace the bend that they knew was going to be wearing out. So they were doing nothing other than just making it an easier job to replace that pressure boundary component. A question that we had a little bit of discussion on, which was picked up from Barry's summary yesterday, was in terms of our operating concern, would there be value to utilities in having an indicator or online indicator of scale thickness? So if you knew where the scale was very bad and you could monitor it, linking back to when you should come down to blow it away, would that be a handy thing? And I think people in general, whilst they're concerned about reliability and technology and cost, feel that if they could have that very cheaply and it was reliable, then they would like to have it. We got into some discussion of hydraulic testing. Rudolf Blum in his presentation yesterday mentioned a difficulty that had occurred at one of the Danish power plants directly as a consequence of hydraulic testing that was perhaps carried out in a non-optimized manner. It's recognized that in many states of the United States, after any kind of pressure boundary repair, utilities are required to undertake a hydro test of the boiler. And there have been lots of issues over what temperature should the water be, what temperature should the metal be, what pressure do you go to on maximum operating, maximum design. So there were a range of uncertainties, and we developed a new word. We weren't satisfied with Barry's OGI, so we have muddying of the scale. We want to try and identify if the hydro testing has a muddying capacity for our future operation. Okay. So we only have two things to do directly with future plants, although clearly what we would say is that we hope the synthesis of information and the understanding we have to help existing plants would carry through into future plants. And one of our big issues that we wanted to put down was we'd heard lots of presentations prior to this workshop and during the workshop over diverse laboratory tests, different methods of doing the test, different durations, different things were just different. Some of these included air-grown scale and steam-grown, influence of pressure, influence of cycling. As Tony had picked up yesterday, there were even differences in measuring how the scale was forming. Was it a weight loss? Was it a scale thickness? And we feel it would be really good if we had defined tests that were relevant to plant, and we had got some agreed methods for measuring the scale, because we think lack of ambiguity or a clearer understanding would really help those of us that are only just learning to spell the word oxide. So that would be very good. And clearly, you'll see from one of our understanding points, we're going to talk about why some things seem to happen differently in different plants. It would be our hope that there would be some opportunity for designing future boiler designs to reduce the risk of exfoliation or to mitigate against that kind of problem. And again, that's learning the lessons from current practice. So, in understanding then, we've got quite a lot of points. Clearly, many presentations, both in this workshop and at other conferences, have talked about pre-treatment and preconditioning, and there seems to be a consensus that promoting a chromium-rich layer is a good thing. When we come to some of the things like peening, do we understand fully how to impose the work, how to measure the work? Do we understand how long those benefits will survive? If we perform a peening or a working operation after a component has been in service for a period of time, is that something which, although economically very challenging, may be a big benefit to performance, and therefore is worthy of some development? So there were a whole range of questions about this pre-treatment, preconditioning, and a validated application guide was a suggestion of how we could bring these kinds of things together. Very much linked to that, an understanding or a concept where we're understanding the influence of surface condition on scale formation. Lots of our laboratory type work has been done on polished samples or ground samples. Most of the plants operate with an acid clean surface. There can be an element of decarburization. There are a whole range of different surface conditions present in the plant that might be present in our laboratory studies. And does it matter? And we're not saying that it does matter, but we're saying we ought to at least ask the question. And then we get into the condition that the plant enters service. Clearly there would have been some kind of heat treatment associated with the wells that were made. In some circumstances, although for none of the manufacturers that are represented in this room, it does sometimes occur that the heat treatment goes too hot, so that the lack of control can be outside of the expected limit. Does that matter? And we don't know if it matters, but we think we should again be asking the question, because what happens is a utility will go along after a period of operation, be it 1 year or 10 years, and they're looking at the condition of the steam side of the component after all these things have happened. So it's basically just tracking through and being able to answer those questions. Very serious discussion associated with performance of some of the austenitic steels, again building up on some of the points that Barry and others made yesterday, that there has been some very serious examples of exfoliation with austenitic tubing. Yet other plants which apparently are operating under similar conditions of temperature and pressure don't seem to have a problem in very long times. And clearly there must be some logical explanation for why that happens, but we don't know whether that's linked to the composition of the steel. Maybe older steels had got less pixie dust than the new steels, and maybe the pixie dust was not helpful. Maybe the processing method, maybe there's a little bit more residual cold work in a straightened steel historically. Maybe that's linked through to something like grain size, which we've seen in various presentations can affect scale formation, yet frequently is not actually documented for any of these tubes before they go into service. And again, the general issue of pre-treatment, maybe unknowingly, the older performance had some kind of pre-treatment which the newer plants do not. And so we felt that some kind of review and comparison would really help there. And my final slide, just building on what John Schiggeldecker summarised yesterday, we want to try and do better with an atlas of operating experience, looking to collate information both from laboratory examination of ex-service tubes, also from tubes that have been generated from test loops, to see if we can put trends in data. Lots of American plants are going to be closed down in the near future. We also think it's handy to look at tubes from plants that have not necessarily failed. One of the things, it tends to be the case that all the laboratory studies on ex-service material tend to be done on tubes that have a problem. There's very little work done on tubes that don't have a problem. So we have to ask that question, is there something there? And that was a general link together. Again, looking at what we can do metallographically from laboratory examination of those laminations on plants which are particularly, show a severely laminated scale from plants that show very limited laminated scale. Maybe there would be some limit there. And we had a large discussion. It's my last bullet point, but it's not the least important bullet point, about solubility and deposition issues for coating. And we had a long discussion about aluminium. Had an interesting review from Doosan about aluminized type coatings. We then got into a discussion about the deleterious effects on creep strength of aluminium in 9-1 steel. And clearly then we got into issues about whether some of that could enter solution and whether it would end up in places you didn't want it to go. So clearly one of our comments about coatings is that we shouldn't just look at coatings technology about the practical or the lack of practicalness of putting the coating on, but we needed to take a holistic view about how that coating might influence the performance of both the boiler and the turbine. So you've had the whistle-stop tour. We've got to the end, and all I would say is, in our group, we had extensive discussions. Everybody contributed very well. There is the opportunity for anybody in our group, if I've not captured what we said and what I said I was going to say, send it in. I mean, it's EPRI's intention here that we capture these, put them together, and then, astonishingly, we intend to actually do something about it.